Okay. Anybody? Anything? Any got any?
Actually, we have a cladded vessel and some nozzles we want to go with solid SS 316L because of size. It is a 2 inch and we want to go with solid. But our client specification restricts that, saying dissimilar metallurgy is not allowed. So something like that. So is there any concern with that? But previously I have done many times, but this particular client is somehow is concerned about that.
Yes, Rama, here it's a galvanic corrosion is the major point.
Okay.
Galvanic series, yes. We had a same problem. One of the Deepak nitrate heat exchanger. Okay. And small nozzles, so they asked us to clad from the inside. We did by the welding somehow. But that because of the galvanic corrosion, they are not allowing us that stainless steel nozzle to be welded directly onto the carbon steel. Yeah.
Okay. No, but how can we avoid it? Because we cannot do the weld overlay. So how did you solve that problem? So
Weld overlay. I think Neeraj is telling. They done welding, right, Neeraj? Weld overlay.
Yes, we did by welding. Pencil torch.
Yeah.
There is a pencil torch which to be used for the Agitator. Yeah.
Okay. So that's okay. Okay, so you mean that is only the way, only the way to.
Yes.
But okay, so now this is what we are talking about is a nozzle on the strut. So it will have a downward run and then there will be elbow and horizontal pipe. So in that case, can we go with elbow and that pipe with SS, and that whether that is okay or still there also problem, you mean?
Yeah, wherever the process fluid come into the contact, see when the galvanic corrosion will take place, anode and cathode roll will come into the picture. So what happen is this cathode have attract the electrons and automatically the rest corrosion will start on the opposite side of the material. So wherever your process fluid will come, it is better to avoid that one. If it is in contact with the process fluid, it is better to avoid.
Okay, I have another one small solution for that.
Yeah.
Is that basically you can use a nozzle, you have to do the overlay, the bottom of the tank or drum, you have to do the nozzle with overlay. And then the connecting elbow and the downstream pipe, the flange, and then downstream pipe, horizontal pipe. You can use CSS, but if you use the insulation gasket kit, then your this electrical continuity is avoided with the use of an insulation gasket kit. And then after that, you can use it. With that insulation gasket kit, you can use. If you don't put the insulation gasket kit, what Mr. Neeraj said is correct. There will be a galvanic couple, and then there will be a corrosion. But
no, actually, this is within the equipment. This is the concern. I mean, actually, this is about the bottom head is cladded. Bottom portion of the vessel is cladded with CS with SS 316L clad. So in that the nozzles we'll do the overlay, but since the size is 2 inch, so we are.
If you are doing the nozzle with the overlay, I think then you can connect the SS pipe, because you have to do only the nozzle. You have to do up to the flange face groove or the rise face. You have to do complete overlay, and then you can connect the SS one. Then because here there is a overlay and the connecting part is also SS, there is no galvanic couple. There is no insulation gasket kit needed.
No, insulation gasket kit is about with the flange, so the flange end. But our concern is in the nozzle. I mean, this is regarding welding actually. Welding with dissimilar materials.
Yeah, I didn't understand the question. Sorry.
Yeah, I also don't understand. But we could not understand your problem. You are clearly audible.
Can you explain the problem, please, once again? Yeah. Apart from galvanic corrosion, there is another damage mechanism. What they see is called as a dissimilar metal weld cracking. When they have the coefficient of expansion or the residual stresses in the weld dissimilar metal joint is high, then some of the clients say that not only galvanic corrosion, we have problem in the dissimilar metal weld joint. If it is not having an aqueous service, no, the galvanic corrosion will not come. But then they are saying that due to high residual stresses in Middle East, they have seen some failures in the dissimilar metal weld joint. That is mainly called because of residual stresses and the thermal coefficient of expansion, and then the constraint joint restraint imposed, something like that during the site welding. They had some issue, and they term it as dissimilar metal weld cracking.
Okay.
Yeah. So when there is aqueous service, you are right. Exactly, the galvanic corrosion has to be taken into account. Other than that, when the aqueous service is not there, if there is anything happening, they call it as dissimilar metal weld cracking.
Right.
So actually, what's Ramakrishna is issue is that he is having the bend and one pipe with bend and then flat nozzle. So in that all the parts he is telling that whether we have to go for this weld overlay or whether we have to go for SS, or as you Vishwanath, you are telling you something insulation you are telling. I think where to connect this insulation and that insulation normally comes after the flange, no? Like that he is asking.
No. What I understand from the problem is there is a vessel, there is a bottom, there is a nozzle, 2-inch nozzle. He first said that at 2-inch nozzle we'll go for solid. Then I think if the vessel is completely cladded, then the solid nozzle can be used, right, Mr. Neeraj? I think if the vessel is completely internally cladded, then they can use a certain type of nozzle, right? Solid nozzle, and then they can weld there, right? With a CRA.
But I think he told that only bottom is cladded or something like that. It's not entire vessel has been cladded. I don't know exactly.
The query was literally not clear actually. That was not so clear what he is expressing.
First he asked about the nozzle, one nozzle, 2-inch nozzle. In that one cladding with that size. Then after that he came to saying that there is a bottom nozzle and that is with bent elbow and with a long pipe. So for that one, how to do like that he is going to. Okay, let's maybe rejoin.
Because if the vessel is internally cladded, he can use a CRA nozzle. It's like SS nozzle he can use and we can weld. Because the vessel is not carbon steel but internally cladded. So he can clad that entire thickness and then he can use a direct CRA consumable and weld the CRA nozzle. And then from the CRA nozzle, he can use the pipe and elbow and other things downstream as direct SS. No need to go for cladded.
Okay.
Correct me if I'm wrong, Mr. Neeraj. Yeah.
Yes.
Okay, I think we'll wait maybe to clarify. Or anybody want to add something in this one?
Yeah, we have a HDSS heat exchanger with monal grading, and my tube sheet was HDSS and the tube was monal, and TTS joint was stamp welded. But after the welding, total welding is not setting as good. You can push backside tube is removing after the welding. We got the solution. Our electrode was not much good quality.
Yeah, but okay, they are going for a monal. I think it is handling. What is the medium it is handling? Seawater?
No, I could not remember right now.
So actually issue is welding with welding, no?
The issue was my tube sheet was HDSS, but my tube was monal. After the welding, when we are doing pneumatic testing, all welding is cracking.
The wrong selection of consumables.
Yeah. By our welding inspector, the wrong selection of the electrode. That's why it was happening.
Okay, Vishwanathan, which one you want to suggest for this type of welding?
This type of welding.
Actually,
this type of welding monal is again nickel alloy, okay, and your super duplex stainless steel, where in super duplex molybdenum is high. I think here it's 5 to 6% moly, and your chrome is also high. Nickel is not that much high. So here you have to have a consumable which will be in monal it's more than 50% nickel, and your SDSS has got hardly 18 to 20% nickel. So here I think we have to go to ASME section 2 part C and select the correct consumable with P number matching. Otherwise, I have to check ASME section 2.
Yeah, I want to ask you one more related to this. My tube sheet is brass. It is a fixed tube sheet and it is the metallurgy with brass, and my main shell is carbon steel. which electrode we have to use for the welding of that lip CS?
Your tube sheet is brass, right?
Yeah, my tube sheet is brass with lip, and lip is welded with to the carbon steel shell.
See, when your tube sheet is brass, that means it is a non-ferrous, number one.
Yeah, yeah,
And you wanted to weld it with carbon steel.
yeah,
I have seen always brazing whenever the non-ferrous is coming to the picture because the melting point is quite low. So
yeah.
I don't think maybe some silver electrodes or silver brazing is recommended for this kind of joint.
Yeah, we are considering, we are putting weld overlay to the CS part, 50 to 100 mm, and brazing brass to brass.
Perfect. Yes, yes. I think that is the correct one.
Okay, Vishwanath, you want to add something in this one? Okay, I think Ramakrishna is back. So Ramakrishna,
Yeah.
you can continue. Yeah, you know it's clear.
Yeah. No, actually, Neeraj said that in his case he has proceeded with this. Weld overlay they have done for 2 inch.
Mm-hmm.
So my actually okay. Let me tell the question again.
Yeah.
So as I told in the bottom head, bottom portion of the head, bottom head is cladded.
Mm-hmm.
So to that some nozzles are being welded. So the few nozzles are 2 inch and below.
Mm-hmm.
So 2 inch size. So we cannot do the weld overlay for 2 inch. Because of our shop restriction. So we want to go with the solid SS pipe elbow and then horizontal pipe.
Mm-hmm.
So this we propose to client, but client specification is not allowing because it is a dissimilar welding. So yeah, that's the concern.
Means CS to your SS welding client is not allowing.
Yeah. It is a welder. The head is a welder. It's a cladded CS with SS316L clad.
Okay, for that one you are connecting SS bottom nozzle.
Nozzle, yeah, because of size, 2 inch. And as Neeraj said, this galvanic corrosion is a concern, but previously in my experience, I've used, no client objected. So we used stainless steel directly. So, but this particular client is having an issue. Is not allowing it. Yeah.
What is the external environment for this equipment?
It is a source service.
See, correct. It's a source service, right? So
Yes.
what happened? Now I think Vishwanath.
Yes.
Yes. Now see here the problem is we are talking about the process fluid come into the contact with the SSNCS, but here when the source service is there, I think the H2S or this due to source service NES requirement, external environment also will be playing very major and important role when actually carbon steel disc from external is welding with the stainless steel nozzle. Correct. So there also this environmental corrosion will start immediately because of this anode cathode problem, because of the galvanic series difference. So at that point of time, from external also this will be start cracking.
The external they will do suggest a painting usually, and they will mitigate with that actually.
Yeah, that is true. But I think after left Ramakrishna, we have discussed that it is a internal SS and process fluid also coming into the contact with SS, and it doesn't have any problem. But the problem is environment. If environment is corrosive, then I think this will be a very good chance of getting hydrogen induced crack from the outside.
In this case, I feel more like client want to avoid sort of dissimilar metal welding. I think in the solar environment.
Exactly. It is a general statement actually.
Yeah, my I am in oil and gas industry only. I have lot of specifications in metal welding. In solar environment mainly due to dissimilar metal weld cracking.
Yes.
Correct.
So they fear, even though it happens or not, but they fear a lot.
Yes.
Yeah.
No, because particularly here the issue is the size. The size is 2 inch that we cannot do the weld overlay. So that's why we want to go with the solid stainless steel. So yeah, otherwise we need to get it done by somebody who can do it.
So there will be I don't know whether there may be change in filler metal you will use to join SS to the overlay, and then there may be some stresses, and the H2S SSE stress is the main concern. So they will try to avoid that actually.
Yeah. Okay.
Right.
Yeah. Yeah. Right. Yeah.
So now, what is the solution now? Whether we have to go with the SS or we have to do the weld overlay?
Yes, specification is governing. Everything is governed by specification.
No, but
So
as Ramakrishna told that it is a bottom. I think I will just share this picture.
Yeah. Thank you. Yeah. You can share. Yeah.
Yours is like this only, no? Bottom nozzle.
Yeah, so my configuration is exactly like this, but except that there are no flanges for the elbow stone. So it is a welded. Okay. So now the actually client is suggesting you have to do the pipe which is welded to the head with weld overlay. You need to do it, but the elbow and the horizontal pipe can be stainless steel. That's what he is suggesting. But my question is, it is again same. No, it is a dissimilar welding. I don't know. Maybe client himself got confused or.
No, here you have the small bottom nozzle is also weld overlaid, right? Actually.
Yeah, actually, that's the small nozzle which is connected to head. Client is saying you do the weld overlay for that. So because which is they want to avoid the dissimilar welding in the main pressure part. But he is saying you can do the dissimilar welding in that pipe, that elbow, and there it is okay for him.
Okay, because now you don't have a dissimilar metal couple because the nozzle will be overlaid, and then you have a nozzle flange also. The bottom nozzle flange face also you will overlay, right? Yeah.
No. Actually, you see that vertical small pipe that is weld overlay. Okay. And
no, that is understood. The nozzle I'm saying is the nozzle connected to the head. You will do a weld overlay. The same nozzle, flange face you will do the weld overlay, right?
No. Actually, the elbow is directly welded to the pipe. Actually, there is no flange joint.
Okay.
So elbow will be stainless steel. He's saying you can do that. But my query is again, it's again dissimilar welding. No.
This is okay. Yes,
yeah.
Okay,
Maybe you got confused or something.
yeah, I think you are right. See, when they are allowing the bottom nozzle welding, then 100 mm away there is a joint. Why they are not allowing that one? It's a little bit difficult to understand.
What is the solution? So whether we have to go with, I think one more flange like in this in shown. So you add one more flange, and that flange you can take as a SS, and where it's connected to shell, that part you can take as a weld overlay.
Okay. Right? Yeah. Maybe your pick will giving me an idea. Maybe we should put a stainless steel with. We need to introduce a flanger joint there.
Yeah.
And put an insulating gasket.
Yeah.
Maybe that.
That is, I think, better
that is an idea. So somehow you picked a random picture, but I think it's giving an idea.
Yeah.
Maybe we will. Yeah.
Neeraj or Vishwanathan, is it okay or anything, any other? Because
I think this is a very good idea. You are avoiding completely this outside welding of SSPCS.
Correct. Yes.
Okay.
Yeah.
Somehow it's come solution, right?
Yeah. Thank you.
Okay. You're welcome. Okay. Any other point?
Yeah, I have one question regarding the welding.
Yeah.
In butt weld, we maintain 30 degree, less than 30 degree angle.
Mm-hmm.
Can we reduce it below 20 or 15 degree?
Sorry, what is the question?
In generally butt welding, the angle is less than 30 degree.
Yes.
Can we reduce it below 10 degree?
Actually, 30 degree to the one side you're saying, Atal?
Yeah, one siding, yeah. 30 degree from one side.
I mean, included angle is 60, you mean, right?
Yeah, including angle is 60, but I want to reduce it to 40 to 50.
Yeah, I think that's okay. This all depends on your WPS and PQR.
Yeah, that we will maintain, but it is okay.
Yeah, it should be fine. I think no issue.
Okay means again
Welding
it's
carbon
a
steel,
yeah.
carbon steel or CRA
No,
or
SS,
stainless steel.
SS and LS. My cell thickness is approx 32 mm.
You should have a qualified, procedure qualification is acceptable, then I think you can do.
Yeah, okay. We will take care of it.
Yeah, Neeraj, you want to add something? Yeah, you can.
No, I think correct, because see, when you are talking about the butt weld, the definition itself is very clear about the maintaining 30 degree or less, because whenever you are joining cell to cone, there also restriction is given in code. If it is more than 30 degree, you have to go with the UW2, because that kind of analysis is not available, because it's not falling directly into the butt weld definition. So, anything less than 30, it's good, no problem.
Okay, thank you. Got it.
Yeah, yes.
So less than that one you can go, but again you have to qualify your welders and that one. WPQs.
Yeah, we will.
Yes.
Okay.
Yeah, is there any code restriction where we should go for beyond a thickness? We should go for double-sided welding. Is there anything like that?
Not required, but generally, sir, in fabrication, we go for higher. If increases, I think 24 or 26 mm.
No. Is there anything, any code in code it is mentioned? I didn't
Absolutely.
see.
No, absolutely no. Absolutely. No. 100% no.
No, nothing is done.
Okay, so I will check it.
Actually, it's based on the experience, because they when you thickness is increases more than 30 or 40, on that time the filling in that area for welder, it takes a lot of time and that heats that portion. That's why they want to make double V, so that one side they will make tack weld and other side they will fill, and then when cools on other side, then again they will fill on means opposite side of that one, like that they'll do.
Yeah, 2/3 and 1/3.
Yeah, 1/3 like that they will weld.
Yeah, right. To the yeah.
So it's
it's all. I mean, it's based on the welding design. I mean, that quality, that WPS
welders and that one. Yeah, quality and also the welders, because how fast. Means some welders they weld with very fast with frequency. So when they weld very fast, then the heat generation also is fast. So due to that one, the bending of that one also is taken. That's why they want to make double V, so that one side when they weld, one side heats, and then when next they weld on other side, then other side will get heated. So the straightness of that plate will maintained, like that they want to do.
And I mean, suppose for some closing seams and all, we cannot do the double welding. So in that case, we need to go for single-sided welding only. If PQR is, the welding is qualified, we can do that also, right? I think that is the only way.
Yeah, if it is completely closed, then there is no option. So we have to go for one side only, and
one side welding. Yes. Okay. So I mean, there is no code restriction as such.
Yeah, code restriction. It's not there. They're not mentioned.
Yeah.
We did 70 mm thick equipment where the closing seam is there. We have to go with the combined V with single side accessible. It's the ISRO's job. We deliver only one side accessible last design. So there we have to provide a combined V where a single side only accessible. So only one side V we have to prepare in 2 stages, and then it's allowed, very well allowed.
Yeah.
So then you made both side V, but you welded only one side, right?
No. V only one side, but it is called combined V.
Means the angle,
double V.
Yeah, angle you use.
V on top of V is trying to.
Yes, only one side. You see, the combined V is from top. It is more than 80 or 90 degree. Then if you go 30 mm down, again the degree will be reduced. So that is called the combined single side combined V.
root run with the TIG, no? I mean, it should be.
Yes. Root run by TIG.
So there are other options, means if not accessible, then we can do with this, as Neeraj said, combine V or that one.
And importantly, when we did the root run, we have provided consumable insert. So another side, automatically the full penetration joint has arrived.
Okay, I think there is a solution. So even when whatever thickness we'll get, so we can do.
And J groove is generally for more than 100 mm. That's the practice. J groove.
Yes. See, we did J groove basically in number of cells and tube to tube joint also we did. So J groove again, it is, see, basically thing is the accessibility of the torch. Accessibility of the torch up to the root. If you cannot fuse root properly, then you will go with any kind of design.
So your torch should enter in wherever you're welding, so that.
Yes, the root should be fused properly. And we have used consumable insert to get that opposite side complete fusion.
So it's again skill of that welder and that one. So how we'll do?
Correct.
Yeah, I have just a basic query about because right now I don't have any project, so I'm designing a vertical vessel, and there is an agitator on the top, but the agitator connection is not via any flanges, nozzle flanges. It's directly coming into the top dish. So how can I transfer the weight of agitator weight into the vessel?
Okay. Anybody want to answer?
But how can you directly? There will be studded outlet, I think.
Yeah, it's a motor. It's a direct opening via pipe.
So you mean it is open?
Yeah, it is open, but it is open, and we can have a opening with a 100 mm circular pipe, and it is upon located agitator, not like a manhole or a plate.
Okay, so means I mean it will be, but how the weight will be acting? I mean how this motor is supported?
Yeah, I'm sharing a snap in the group. I just shared.
Yeah, or you can share here the screen. Okay. It's studded outlet only, na?
Yeah. Only studded outlet.
Yeah. So there it's like you can define a studded outlet, and you can define the loads.
Yeah, how can I define the load, like portion moment or weight?
Yeah, actually the load should come from the agitator vendor.
Yeah.
The agitator vendor should give it. Generally, it will be vertical force and movement.
Yeah, actually, the vendor give me only weight, and he's saying we will provide after PO everything.
So right now you can put that whatever you can assume something and put it and keep the different thickness on board. Okay, and you proceed for now, and after getting the actual loads, then you can finalize.
Okay, because it is a random designing. Okay, thank you.
Yes. So that's the way. Yeah. Yes.
Okay. Because someone told me if there is a nozzle, you can directly put it into the double.
Yes. It is a studded outlet, no? So you can define a studded outlet, and whether you know the size?
The size of outlet.
Yeah.
Yeah, it is a 100 mm wide pipe.
No, but the I mean, you see that yellow part is connected, so that seems to be bigger. Maybe you can find out.
Yellow part is bigger. It's approx 750 mm.
Correct. Yeah, but where this opening is attached is see that where you are finding the holes. So that size seems to be bigger. So I think it's not 100 meters. It is much bigger. Just check it.
Yeah. Okay. Sure. Thank you.
Okay. So Atul, your query is just what are the loads coming? As Ramakrishna told that it's considered as a flange which directly fitted on the dish.
Yes.
So on that one you apply the loads whatever this motor or is giving by vendor. So you apply that load on that one. So
Yes.
accordingly you can calculate. So okay.
Okay.
Okay. Any other issue?
Okay, so Amrut here. I just want to add one thing here.
Yeah.
So actually, this is the agitated, and for agitated case, what Ramakrishna said, it is correct. We should consider it as a normal French connection, and we can ask vendor. Means for agitator case, agitator vendor always provide 3 moment and 3 process, which we generally consider for that nozzle calculations. But in case now this is, I think, before PO stage, and maybe vendor is not able to provide. Even I guess vendor is not fixed that motor size and all. So maybe he don't have that much of all detailed data in his hand. So one thing you can consider, it is just a weight thing, and you just consider the maximum moment. So weight is not matter for that agitator calculation, mainly the moment, and that moment is depend on that you just posted your that image in the group, and that yellow sharp length we can say from top of head to upper side. So you at least consider 2 to 3 times moment for just for conservative side to avoid any cost claim letters from tower vendor or vessel vendor.
Yeah, sure.
Atul, you can also request vendor to give the preliminary load. So just to proceed. I mean, you can try that.
Is it Atul, it's a preliminary or it's now order is already given to it?
No, it's a preliminary because I have not too much project, so that's why I'm practicing for vessels.
Okay. So
you can try for try to get the preliminary loads from the vendor.
Yeah, I will get.
Or you can find some references.
or you can request them the
But
way.
second thing, I just seen the thickness of that head you consider 91 mm. So I think it's more than enough, and no agitator can, it's more than enough for that agitator. In case that head thickness is
91
20 or 30.
It's at 9 mm only, 9 teeth thickness.
9 thickness.
Oh, okay. I thought it's 91 mm.
No.
Let's say I said 91, then it's completely okay.
Yes. What's the diameter, Atul?
2050.
2050 and pressure?
And so pressure, inside pressure is 4 bar.
Okay.
It's not that much.
Yeah. Maybe okay. Or what you can do, maybe just for conservative purpose, you can take a little bit higher. Maybe it is okay, but accordingly you can take decision. Yes.
Yeah. Finally, once you get the realistic value, only you can go further. Otherwise,
Even that dish you keep it on hold until that time.
Yeah, until the loads you'll get the firm loads.
Yes.
Yeah. Okay. So if something went wrong after PO, or anything, so only dish will be major impact.
Dish also, the total weight and the bottom what supports coming, that also means it's total things will be changes now.
So because of weight, I don't think it will have any issue. Do you have any kilowatt something? How much kilowatt motor? Something
I think it is a 50 kilowatts.
Okay. So what you can do, maybe you can see in internet what is the weight of particular. I mean,
total agitator weight is 1500 kg.
Okay.
So you already have that weight.
Yeah, I already have that. Yeah.
So you take little bit extra. Maybe you consider 2000 and proceed. So So that dish part, maybe that local analysis, you need to keep it on hold. Yeah.
Okay.
And I think no need of any fatigue like that. It is not required. I think it is by previous experience. I think this kind of thing work. I don't think it fatigue like that they will ask for. So it is generally
No, they are not asking for fatigue.
asking.
Yeah. I asked for them. They denied.
Yeah. No, because these reactors, generally I think they have many years of experience. So that's why generally they are okay with it.
Sure, sir. Thank you.
Okay, then you got your answer.
Yeah, I got it.
Any other things? Any other issues? Yeah, Anshul, you want to say something?
Sir, I need to leave actually.
Yeah. We are also on the. Okay, I think no issues, so we can wind up.
Yes.
Right.
Okay.
Yeah, also I want to leave, so I think if you're wind up, it's okay. Otherwise, I leave, sir, because
Yeah.
I'm in Malaysia.
We'll
It's
winding up.
11:20 now here.
Yeah, we'll wind up. Okay, no issues. So we'll. Okay. Okay, then good night.
Good night. Good night. Good night.